June 2021, paper 3, variant 1. Question 1, figure 1.1 shows a speed time graph for a car. Okay, speed time graph. Describe the motion of the car from 0 to 50. Describe the motion of the car from 0 to 50. What is happening to the motion? Constant speed of what? What was the exact number of his constant speed? Uh, constant speed, constant speed of 6 meters per second. Yes, exactly. Describe the motion of the car from 50 to 90. From 50 to 90. What was happening to the motion? Speed was decreasing, صح? Decreasing or constant deceleration. Yes, you can say constant deceleration, or you can say that the speed was decreasing, or whatever, as you like. So you have a lot of answers, and most of them would be correct. You could say deceleration. You can say deceleration. Can I say deceleration? Do I have to say constant deceleration? No, you don't have to say constant deceleration. Can I say speeding, slowing down? Yes, I can say slowing down. Okay, speed decreases, whatever. Calculate the distance traveled between 50 and 90. Can I find the distance traveled between 50 and 90? Definitely. Mr. Should I say distance equals speed times time? Definitely not. That's wrong. If you have a speed time graph to find the distance traveled, you should say the area under the graph. So area, and you need to explicitly write it this way: area under the graph, which is this is triangle half times base times height, which is half times from 50 to 90, from 50 to 90, which is 40. 90 minus 50 is 40. So half times 40 times the height, which was 6 meters, which is 120 meters. Okay, 120 meters. In B, a motorcycle travels at constant speed. He travels 710 meters in 87 seconds. Can I find the speed and show that it's close to 8 meters per second? Yes, I can do that. Speed equals what? Or average speed equals speed equals distance over time, which is 710 over 87. Using your calculator. Using your calculator, 710 divided by 87 is 8.16. 8.16 is very close to 8. 8.16 meters per second, which is definitely very close to 8 meters per second. Motorcycle in part B travels at a constant speed for 87 seconds. Part BI, this one, okay? He travels at a constant speed for 87 seconds. Draw the constant speed, okay, or draw the speed time graph for the motorcycle. Can I draw the speed time graph for the motorcycle on figure 1.1? Okay, he's being very clear. On the figure, on the graph, can I draw the speed of 8 meters per second? Yes, I can draw the speed of 8 meters per second. For how long? For 87 seconds. So starting at time 0, he was traveling at a speed of 8 meters per second. Constant speed, so I'll draw a straight line, okay? A straight line all the way up to 87. All the way up to 87, which would reach this point. If I can zoom in, okay, it should reach this point. So constant speed, 87 seconds. Constant speed of what? Of 8 meters per second. Okay. Now, moving on. Next question. A liquid in glass thermometer. Okay, so actually thermometers have been removed, but we can solve part A. We can solve this part. Can I find the weight of the mercury? Yes, I can find the weight of the mercury. Weight equals mg. Weight equals mg. So most of you would say 12 times 9.8. Most of you, I'm saying most of you might say 12 times 9.8, which is very close to 120 newtons, which would be wrong. Why would it be wrong? Because first of all, you need the mass to be in kilograms. The mass must be in kilograms. So 12 divided by 1000. Mass, to find the weight, mass has to be in kilograms. So 12 divided by 1000, which is 0.012, if I'm not wrong. Okay, 0.012. Then this is the mass, 0.012 kilograms times G, which is 9.8. I know this is an old exam. The G was 10 back in the day, but for now it's 9.8. So yeah, L, let's calculate it. 0.012 times 9.8, which is 0.1176. 0.1176. Should I write down all of these numbers? No. You could write it down as, let's say, 0.12 or 0.118. Okay, three significant figures. 0.12 newtons. Can I find the density of mercury? Yes, I can find the density of mercury. Density equals mass over volume. 12 over 12 over 0.88. 12 divided by 0.88 is 136. 136.3, 166.4, 166, 36, that would be enough. 136 grams per centimeter cubed. Okay. Um, did I write? So I'm sorry. It's yeah. I added an extra zero. I'm sorry. It's actually 13.6. Oh yeah, I know. 13.6 grams per centimeter cubed. I was like 136. That's too much. Something's wrong. So when I checked my calculator, I actually added an extra zero. So it's actually yes, 13.6 grams per centimeter cubed. Part B is cancelled. You're not required to solve thermometers, so part B is cancelled. It has been removed. You're not required to solve it at all. A plank balances horizontally on a log of wood. Can I find the moment of the girl's weight about the pivot? Can I find the moment? Yes, moment equals what? Moment equals force times perpendicular distance. The moment force is 404 times 1.2. 404 times 1.2. This would give you a moment of 484. Okay, 484.8 exactly. Okay, 484.8 newtons dot meter, which is very close to 480 newtons dot meter. Okay, the plank balances horizontally when the boy pushes down with a force of F at a distance of 1.6 meters from the pivot. Can I find the force F? Yes, I can find the force F. Moment, clockwise moment. This is balance, so you should say that the clockwise moment is equal to the anti-clockwise moment. Clockwise moment is equal to the anti-clockwise moment. The boy, okay, the boy is exerting a force of the boy is exerting what force? The boy is exerting a force of F times the distance of 1.6. He's exerting the clockwise moment, while the girl is exerting an anti-clockwise moment, which is equal to 480. Should I use 484.8 or should I use 480? It wouldn't really matter. Okay, it wouldn't really matter. If you use 484.8, then the force would be around 303. If you use 480, okay, it would be around 300. It would be around 300 newtons. Okay, all you do is divide by 1.6. It wouldn't be wrong. Again, it wouldn't be wrong. If you use 484.8 divided by 3, the final answer would be around 303, which is correct. It is okay. If you write down 303 or 300 newtons. Okay. A country needs to build new power stations to provide electricity for homes and industry. One type of power station is a coal-fired power station. Describe how the energy stored in the coal is used in a fire cold in a coal coal-fired power station to generate electrical energy. Um, how do we use it? How do we generate electricity from coal? First of all, what is the type of energy stored inside the coal? You need to ask yourself this question. The type of energy stored inside the coal is, it should be chemical energy. So chemical energy, you can say as coal is burnt. Chemical energy changes to what type of energy as you burn it? It changes to thermal energy. To thermal energy. And this thermal energy, this heat is used. How? How can we use this heat? It's used to, yes, to heat up water. It's used to heat up water, huh? Which is used to heat up water. Someone saying it makes steam. Steam turns the turbine. Turbine turns the generator. Generator generates electricity. Definitely, this is 100% correct. Okay, to heat up water. Okay, which turns to steam. Okay, then the steam rotates. Okay, rotates a turbine. Okay, a turbine. Kinetic energy. You can say that this is kinetic energy. This is kinetic energy. Steam rotates the turbine, which is kinetic energy. Turbine rotates a generator, which produces electrical energy. Electrical energy. Okay. Easy. Yeah. Water. احنا in this question we need water. Why do you need water? Because the heat itself cannot rotate the turbines. You cannot rotate the turbines using the heat. You need to convert this thermal energy to some sort of kinetic energy to rotate the turbines. So you need the water, you need to boil the water and change it to steam in order to rotate these turbines, which are attached to generators. Some people in the country argue that building a new coal-fired power station against them. They don't like it. They say that the power station is expensive and not very efficient. It's not very efficient. What does it mean when I say not very efficient? What do I mean by not very efficient? Not very efficient means that wasting. I'm wasting a lot of energy, a lot of the input energy, which is very true in the coal-fired power station. Most of the energy is actually wasted to the environment. Okay, wasting. Okay, a lot of the input energy. Okay, not useful. Okay. Apart from the cost and efficiency, give two other reasons not building a coal-fired power station. Why shouldn't I build a coal-fired power station? Definitely pollution. What type of pollution? You need to say air pollution. You could say non-renewable. You could say greenhouse effects, global warming. You could say so, non-renewable, non-renewable. Can say air pollution, global warming, acid rain. Okay. Can I find the resultant force? Yes, I can find the resultant force. Just subtract. You need to subtract these forces. So 20 minus 12 is 8. And direction is forward to to the right. Forward or to the right. Well, after a short time, the suitcase is moving at a constant speed. After a short time, it's moving at a constant speed. What could the value of the pulling force be, and what could the value of the friction force be? If it's moving at a constant speed, if it's moving, okay, at a constant speed, it could be someone saying 10 and 10, okay, 8 and 8, 12 and 12, 100, 20 and 20, it's okay, okay, whatever two numbers, but they have to be equal. They need to be equal, okay? They must be equal. Okay, yeah. Can I find the pressure? Can I find the pressure? Yes, definitely I can find the pressure. Pressure equals what? Pressure equals force over area. Pressure equals force over area. So the force is 150 newtons and the area is zero point 0.6 centimeters squared. This would be the total pressure. Would this be correct? 150 over 0.6. I don't think it's right. Why would it be wrong? Why would it be wrong? Because the suitcase has how many? Has how many wheels? It has two wheels. Has two wheels. And he said that each wheel has an area of what? Each wheel has an area of each wheel has an area of 0.6 centimeters cubed. So force over 150 over 0.6 times 2. 0.6 times 2. 150 over 0.6 times 2, which is 150 over 1.2. The total pressure would be 120 125 newtons per centimeter squared. And that's why this question is worth 4 marks. Because the area, okay, because the area of the wheels, okay, 0.6 is the area of only one wheel. Each wheel, each wheel has an area of 0.6 centimeters cubed. But the total area of these two wheels together, is 0.6 times 2, which is 1.2. This is the total area. Okay. Figure 6.1 shows a smoke cell. Okay, it's moving this motion. State the term used for this motion. What is this motion? This motion is called what? This motion is called the Brownian motion. Definitely. Brownian motion. Explain why the motion, or explain the motion of the smoke particle. Why does it move in this way? Why is it moving in this random zigzag motion? Gave you part of the answer. You have to say that these smoke particles are hit by what? Are hit by air molecules. So you need to say that the air molecules, air molecules move fast and random. Move fast and random. Colliding with the smoke particle, with the smoke particle from all directions, directions, causing this random zigzag motion, causing a random zigzag motion. You have to say that the air molecules collide with the smoke particles. You can't say it's the other way around. Okay, you can never say that the smoke particles collide with the air molecules. This is wrong. Air molecules collide with smoke particles from all directions, causing this random zigzag motion. Brownian motion. Okay, narrow beam of white light. Can I state the colors? The colors are Roy Gibev. Roy Gibev. I know you don't have the seventh dotted line. You can just write the violet here or whatever. Roy, red, orange, yellow. يلا, red, orange, yellow, green, blue, indigo, and violet. State the term used to describe the bending. Okay, most of you would be tempted to say that this is called dispersion. Why? Because the light has been dispersed. I have seven colors, but the bending is called refraction. Yes, refraction. Excellent. The different amounts of bending producing this spectrum. How can I produce the spectrum? By dispersion. By dispersion. The student incorrectly writes some sentences about the electromagnetic waves. Um, the speed of light is faster than the radio waves. No, definitely it's the same as the radio waves. X-rays are used in television remote controllers. Do we use uh, X-rays? No, definitely we use the infrared. Yes, infrared radiation. Um, Radio waves have the highest frequencies. No, definitely the gamma rays. Yes, excellent. Okay, we don't have any radiation which has a frequency greater than the gamma rays. Okay, no frequencies greater than the gamma rays. Okay, a loudspeaker producing a sound. Choose words. Yeah, to increase the loudness. To increase the loudness. I need to increase what? The wavelength, speed, frequency. It's definitely the amplitude. Um, to increase the pitch, to increase the pitch has to do with the frequency. Yes, the pitch has to do with the frequency. Can I find the total distance the sound travels during the 0.56 seconds? Sound, she's now hearing an echo. Hear an echo. So the total distance would be 80 plus 80. 80 going to the brick wall and 80 coming back, so it's 160. 80 plus 80. Total distance. Calculate the speed of sound in air. Can I find the speed of sound in air? Definitely the speed. This is an echo. Speed equals distance over time. Yes, it's distance over time, but you need to find the total distance traveled. The total distance traveled, which is 2d over t. So speed in an echo is 2d over t. 2d, we already found the 2d, which is 2 times 80. 2 times 80 over the time, which is 0.56 seconds. Okay. 2 times 80 divided by 0.56 would give you a speed of around 290 meters per second. Okay. 0.56 seconds is the time taken for the sound to travel all the way to the brick wall and back. It's the time taken for the whole process, the whole reflection process to happen, the whole echo. Okay. The student's values for the speed is not accurate. Okay. Is it wrong to write decimals? No, it's not wrong to write decimals. Okay, if your answer is in decimals, you can write it. But again, in physics, it's better to write down only three significant figures. It's better to write down only three significant figures. Um, Two ways to improve the student's experiment. How can I improve this experiment? How can I improve this experiment? Definitely, first of all, you have to say that this distance is too short. This distance is way too short. So you need to increase the distance. You need to increase the distance. Someone can say, repeat and take average. Okay, we can repeat and take average. Someone can say, use a sharper sound. Sharper sound. Okay, we can say all of these answers. Increase distance. Can say repeat and take average. Repeat and take average. Why should I increase the distance? Because 80 meters is quite short for the sound waves. The speed of sound is usually around 330, 340 meters per second, and we found that the sound is 290 meters per second, which is off by around 50 meters per second, which is a lot. So if we increase the distance, the time taken would kind of increase. 0.56 seconds is such a short time for us humans. Okay, and then don't forget that we need to include the human error and whatnot. So 0.56 seconds is too short of a time, and 80 meters is too short of a distance. You need to increase the distance, and therefore the time would increase, and probably the speed of sound would be a bit more accurate. All the materials that are electrical insulators, definitely plastic and wood. Plastic and wood. The one sample of a magnetic material, he's being very specific, a magnetic material is iron. This is the magnetic material. Figure 9.1 shows two magnets P and Q, which are repelling. They are repelling. Can I write down the poles of Q? Yes, I can write the poles, the remaining poles. If this is an N, this is an S. They are repelling, so this has to be an S, and this has to be a north pole because they're repelling. State one other advantage of an electromagnet compared with a permanent magnet. Huh. Advantage of an electromagnet. Okay, someone's saying that we can it has a high strength. You can you can change the strength of the electromagnet. You can change. You can't say this is. Yeah, if you say high strength as an answer, it would be wrong. It would be wrong. Some more suitable answers would be that we can switch it on and off. We can switch it on and off. Yalla, can be switched on and off. A student wants to make the strongest. How can I increase the strength now? How can you increase the strength? What should I do to the number of coils? Number of coils. Definitely, I need to increase the number of turns. 200. What should I do to the core? Iron, air, plastic. Plastic? Yes, it should be iron. What about the size of the current? I need to increase the current. Or should I decrease it? Huh? Increase the current. So 20. The answer should be 20. No, it shouldn't be 20. Why? Because this is 20 MA. What's MA? Is it meter ampere? It's 20 meter ampere. No, it's not meter ampere. It's milliampere. So it's milli. Milli means that you need to divide by 1000. Milli whatever. Milliamperes, millivolts, milliseconds, milli whatever, you need to divide by 1000. So actually this is 0.02. This is 0.02 amperes. It's not 20, it's 0.02 amperes. So actually the largest current would be 3 amperes. You need to increase the number of turns, you need to increase the current, and you need to add an iron core. Iron, not steel core. Determine the resistance of the 3 ohm and the 5 ohm resistors. Definitely it's 8. They're in series, so we just add them up in series. The reading on the ammeter is 0.5 amperes. What's the reading on ammeter Y? 0.5 amperes, so current equals V over I, so I should find V over R, so I should find 4 over... شباب, this is a series circuit. Let's say series circuit. The current at any point in this circuit would be the same. So the current in this ammeter is 0.5 amperes. The current in this ammeter would also be 0.5 amperes. Okay, current in any ammeter or at any point in this circuit would be 0.5 amperes. The lamp and the resistor have changed from series to a parallel, connection or combination. State and explain the effect this has on the current. State and explain the effect this has on the current. What will happen to the current? Current would increase, decrease. What would happen to the current? current would increase. Why would the current increase? Increases. Current increases. Why? Because the resistance decreases. Why? Because you can say that V equals IR. V equals IR. It would be, yes, it would be less than 3. Yes, it would be, the resistance would be less than 3. V equals IR. They are inversely, they are inversely proportional. They are inversely proportional. Okay? Hmm. Easy, صح? Yeah. As you add the resistors in parallel, what happens to resistance? It decreases. Okay, if resistance decreases, it becomes less than the least resistor. Less than what? Less than 3 ohms. Becomes less than 3 ohms. Okay, I know we had 8 ohms when they were in series. When we add them in parallel, it would be less than 3, less than the least resistor. So the current increases. The current is 0.4 point 0.4 and the voltage is 6. Can I find the resistance of the lamp? Yes, of course. Resistance equals R equals V over I, so 6 over 0.4. 6 over 0.4 is 15. 3 very easy marks. Extremely easy marks. Hmm. Okay. A student is using a coil and a magnet on a spring. The student pulls the magnet through the coil axis. He's pulling the magnet through the coil until it reaches point X, and then he's releasing this magnet. It's attached to a spring. So you're pulling the spring, okay? When you release this magnet, what happens to the magnet? It keeps on oscillating. Keeps on oscillating. So state the type of voltage induced in the coil. Hmm. Yes, it is. It is definitely alternating. Why is it definitely alternating? Because it keeps on moving up and down. The magnet keeps on cutting the coil. Magnetic field keeps on cutting the coil. So as the magnetic field cuts the coil, what happens? It produces an induced current, not just any induced current, actually an alternating induced current. An alternating induced current. State two ways of increasing the voltage induced. How can I increase? Why is it alternating? Because it keeps on moving up and down. The magnet keeps on moving up and down. So as it changes the direction of motion, it changes the direction of the current induced. How can I increase the voltage? How can I increase the voltage? Ah, can I increase the strength of the magnet? Yes. Can I increase the speed? Okay. Can I increase the number of coils, the number of turns on the coil? Yes. Okay. Increase the strength of the magnet. Increase strength of the magnet. Increase number of turns. Number of turns on the coil. Can do whatever. State which two nuclides. Yeah, state which two nuclides um, have the same number of protons. Which of these have the same number of protons? Definitely. Yes, uranium 235, um, uranium 235 and uranium 238. You can just write uranium 235, 238. Which two nuclides have the same number of nucleons? Same number of nucleons. Ah, 238 and 238. So plutonium 238 and uranium 238. State which one of these four nuclides has the most electrons orbiting when it's in a neutral atom. Which of these has the most electrons? To find the most electrons, you need to look for the most number of protons, which is basically plutonium. So plutonium 238. Plutonium 238. Thorium. Why is thorium wrong? Why would thorium be wrong in a double I? Because he's asking which of these two nuclides have the same number of nucleons. Nucleons means the mass number. So the mass number, we need to find 238 and 238. Both of them have the same mass number, meaning that they both have the same number of nucleons. Nucleons is the mass number. Okay? Can I write in II plutonium and thorium? Again, no, you cannot write down plutonium and thorium. Why? Because they do not have the same number of nucleons. Okay, they don't have the same number of nucleons. They might have the same number of neutrons. Ah, now I understand why you think it's thorium and plutonium. Nucleons is not neutrons. Nucleons is not neutrons. Nucleons is the mass number. Is the mass number. Neutrons is a totally different thing. To find the neutrons, yes, plutonium 238 and thorium 234 have the same number of neutrons, which is okay, that's correct. But they don't have the same mass number. They don't have the same nucleon number. We have to memorize this word. Nucleon is what is the mass number. Okay. Thorium 234 has a half-life of 24 days. Calculate the mass of thorium remaining after 72 days. The initial mass was 40 milligrams. After 72 days, what happens? Well, we need to check. How many half-lives are there in 72 days? How many half-lives are there? 72 days, which is the total time divided by the time for one half-life. 72 divided by 24 is what? 72 divided by 24. That's a very difficult number. It's what? 3 half-lives. It's 3 half-lives. What do I mean when I say 3 half-lives? I mean that I need to divide by 2 how many times? 3 times. Need to divide by 2 how many times? 3 times. What's the number that I will divide by 2? 40. Not 234. You need to divide the mass. Not the mass number, the mass, the actual mass of the sample. So 40 divided by 2 is 20. Divide by 2 again. 10 divided by 2 again is 5. So I divide by 2 3 times, which is 5 milligrams. 5 milligrams. Okay.